Hello, this is Melissa Spalding, and I am going to be presenting my research project on estimating and characterizing escapement of Pacific salmon in the Chena and Salter rivers of Fairbanks, Alaska. So Pacific salmon in general are labeled as a $3 billion industry, and they support both subsistence and commercial fishing. The U.S. commercial landings of salmon is valued at $489.1 million, and in 2017 in Alaska alone accounted for 96% of that. The seafood industry is important to the people of Alaska, with it providing almost a quarter of all the basic private sector jobs. With that, salmon is the most profitable and fished for species, which is why we need to regulate them and monitor them and their fluctuating population. So the species I'm looking at is Chinook salmon. They are the largest species of Pacific salmon. They are well known for sport, sustainable, and commercial fishing, and they differ in Atlantic salmon in that they die after they spawn. And so this is a photo describing the escapement. So you can see from this that the different colors are different populations of salmon. So escapement is the term used for when anadromous fish escape being caught by fisheries, so either commercially or recreationally, and they successfully return to their birthplace to spawn and reproduce. So getting the escapement provides us with the abundance and distribution of these populations, and it can tell us how far they migrate out into the ocean and how far they come back in to spawn and at what ages and stuff. So my research was conducted on the Chena and Salter rivers, like I already said, and these rivers come from the Yukon River. So fish come in from the Bering Sea and they swim up the Yukon, and then they swim into the Tanana, which is where Fairbanks is, and then the Tanana is where the other two rivers I'm looking at come from. So the Yukon River is the largest river in Alaska at almost 2,000 miles, and the Chena and Salter River are important spawning sites because they support the largest Chinook spawning populations in Alaska from the Yukon River. So what I want to do is characterize and enumerate this escapement of the salmon. So I'm going to get age, sex, and length, and I'm also going to get them from both rivers along with the total with the help of technicians and biologists from the Alaska Department of Fish and Game. And what I'm going to do is compare it to the 25 years of data I get from them to find trends and correlations. For my methods, I conducted sonar and visual counts. So our visual counts on both rivers, we put a scaffolding tower, and we have a white panel that lays across the bottom of the river so you can easily see the salmon. And we also have fog lights. Doesn't get very dark in Alaska, but when it does, it helps us see. And then we also have sonars in the water that collect 24/7 data to get us accurate total count. So the visual counts were only conducted for the first 20 minutes of every hour for the whole run, just to give the public kind of a faster count in the morning so they know during out the day if they can fish that day. And then, like I said, the sonars do 24/7 data. At the end of the run, we did carcass surveys. So these gave us the age, sex, and length data. So once the fish are spawned out, they die, they're in the river, we use spears to collect them, and we put them on a gravel bar with their left sides facing up, and we collect their scales for age, and then we use a vernier caliper to collect their lengths, and then their sexes are known by their jaw structures. And once we collected all this data, we would slice them on their left sides that are facing up and throw them back in the river just to make sure we don't resample them. So once I got all of this, I conducted data analyses, and so this figure you're looking at now is the total number of salmon over time. So I can see there's a significant decrease, and our maximum amount of fish was in 1997 with almost 14,000, and in 2013 we had less than 2,000 salmon. There were no significant difference between the two rivers, but over time there's a significant difference in the number of salmon. This figure shows the proportion of ages over time at the Chena River. So as you can see, most years are composed of 4, 5, and 6-year-olds, and there's a very small percentage of 3-year-olds and 7 and 8-year-olds that come in to spawn. Same thing you see at the Salcha. The main ages are 4, 5, and 6. But as we can see, the 7-year-olds used to come in at almost over 10% of the total population, and now we're lucky to get over 2%. So we know that the fish are spawning at younger ages than they used to be. The Chena River tends to have more males than females. This is a figure of the male to female ratio in the Chena River. So this line at 1 represents 1 male per female. So we can see most of them are going to be more males than females. And we had 1 year in 1995 that we had 0.93 males per female. So we had a little bit more females than males. And then the data points that are 0 have no data because of decomposition, so we were unable to get a accurate sex. We see the same thing in the Salcha. We have more males than females, and then this time we have 3 years where we had more females than males, but most commonly they are males, and the Salcha averaged 1.3 males per female, but going back to the Chena River, they averaged 2.5, and in 1993 we had 7.5 males per female, which is a lot. And then also in 1993 for the Salcha we had a maximum of 3.5. So in that year there was a very high amount of males per females. This figure shows lengths between the 2 rivers of males and females. So you can see males, so the blue is Chena and the red is the Salcha River. So the Chena River males are much bigger than the Salcha River males, while the females in the Salcha are larger than the Chena, which is weird. But you can see that there's a significant change there. So oceanic factors may be the primary reason why we see these differences in salmon, because Pacific salmon live most of their life in the ocean and they only come back to fresh water to spawn. My research may contribute to fisheries and salmon biologists in providing evidence of change over time, and my research shows that there is something going on in the ocean that's causing these changes. There's a paper I found by Wells et al. That looked at Pacific salmon and the oceanic effects on the characteristics of run, and these factors can include sea surface temperature, river flow, gyres, upwelling, and the nutrients other salmon provide when they are already spawned out, and also seasonal coastal conditions. So with this research I've done, fisheries may be able to set regulations of fishing to maintain the populations we have or increase them by having salmon hatcheries as well. So I would like to thank the Alaska Department of Fish and Game, biologists and techs for helping me get all these visual counts. I couldn't have done that without them. I would also like to thank the Ocean Studies faculty for helping me throughout this whole process, and especially Ann Cleveland, my research advisor, for dealing with me. Thank you.